So now we're going to look at graphing linear functions. We've already done some by using equations and making tables of values, and we've also generalized how by using that slope and one point of interest, usually the y-intercept, we could actually graph the line. Now we're going to be looking at, given an m value and a point, now how do we graph the line? Or given 2 points, can you find the slope? Or if you have a slope and you have a point, can you find another point? So these are the types of problems we're going to be looking at now with graphing. So let's take a look at one example where we're given the slope is -2/3 and a point -4, 5. First things you want to look at is then at -4 and 5 we will want to have a coordinate point because that's a guaranteed point that we know about. So -4, 5 exists on the graph. Now how do we use m to then find the rest of our points? Well, m is your rise over your run, your change in your y's, all over your change in your x's. So the change in your y value is -2, and the change in your run is +3. Or you can have it as your rise is +2 and your run is -3. So there's 2 ways of looking at it when you have a fraction that is negative. Either your numerator can be the negative or the denominator can be the negative. So if our change from where we're starting at to at -4, 5 is a rise of -2, we can go down 2 units, 1, 2, and then we can go run positively 3, 1, 2, 3 to find our other point. So we'd have a point at -1 and 3. If we were to use our rise as +2, we would then go up 1, 2, and we would go -3, so 1, 2, 3. So we'd have another point here. And from this we can then continue the pattern. It doesn't matter which point we start or end from, we can either go up 2 over to the left 3, or we can go down 2 or to the right 3, and we'd get our full line. Now if they asked us for another point on the line, any other point on the line, this is our point that we're given, -4 and 5, we can then say that -1 and 3 is also a point. We can also now say that -7 and 7 is also a point. And again, we can continue the pattern on and find other points as well. Now another thing that's quite important and that they'll talk about a fair bit in the book, and we've already talked about a little bit last unit, is y-intercepts and also x-intercepts and the number of intercepts in general. So x-intercepts and y-intercepts they have special properties. If you're given any line, it doesn't really matter what slope you have, every line will hit the y-axis and the x-axis at least once, or at most once I should say, if it has a slope that is positive or negative and not 0. If you have a 0 slope, you will only have a y-intercept and no x-intercept. If you have a vertical line, you will only have an x-intercept and not a y-intercept. So those are 2 special cases, but on a general line, as long as the slope is not undefined or 0, you will have only one x-intercept, only one y-intercept. The x-intercept will always have a coordinate point of value for x and 0 for y. The y-intercept will always have some value for y and always 0 for your x. These can be used as points to help you find the slope. So you have to know that when it says an x-intercept, if it says an x-intercept at 2, that means you have a point 2, 0, which can be used for your calculations of slope or in your equation of a line. It's a point. It's actually a coordinate point. If I tell you you have a y-intercept at -2, then we know we have a point 0, -2. So again, you have to know that when it says something to the effect of either of these two statements, that it translates into a coordinate pair that you can then again use to find your slope, find the equation of a line, etc. In this section as well, we'll be looking at some word problems, and some of them may involve some algebraic work. You could do it graphically in this particular case, but it's best to know how to do the algebraic approach, because there will be some that will work out to fractional amounts or decimal amounts that you will need to actually calculate. So if we look at this one here, it says find a number b, and let's make it a capital B so it looks, there you go, so that the line passing through 6 and 2 and 4 and b have the slope of 2 over 3. Now you know that your formula is this, and we have all the information we need. Your m value, your slope, is actually 2/3. Our y value is going to be b minus 2 all over 4 minus 6. So now we need to figure out what is the value. What can we do to do this? Well, 2 over 3 is going to equal then b, which we don't know, minus 2, and 4 minus 6, so we get negative 2. Now this is going back to our idea of solving for the variable. Right now, on this side of the equation, we are being divided by a negative 2. If I want to get b minus 2 by itself, we have to multiply both sides by negative 2. So we'll take this and we multiply by negative 2. That will then cross out the negative 2 in the numerator and the denominator on the right hand side, and it will leave us with negative 4 over 3 is going to equal b minus 2. Okay. Then we want to get b by itself, so in order to do that we have to isolate the b by adding 2 to both sides of the equation. So negative 4 over 3 plus 2 has to equal our b. Working with fractions, you need to have a common denominator. Denominator is 3, therefore this makes it 6. So then as a result, we get 6 minus 4, so 2 over 3. So 4 comma 2 over 3 is our point. 2 over 3 is our b value, where these 2 points will have a slope of 2 over 3. Just so happens to be the same value. Not necessarily always the case, but this is a case that if we did graph it, we could estimate it, but if we do it algebraically, we can get an exact amount as a fraction or as a decimal. In this case, best to leave it as a fraction because it is repeating.